In the last lecture, we looked at the case where we had two lines that crossed each other, which left us with a set of four angles, or eight angles if you want to count the straight angles. So, what happens in the situation that we have here, where we've got two lines in a plane that don't cross? Well, as it is, the answer is not much. By themselves, there isn't a whole lot that we can say about two non-intersecting lines. We do have a name for them. They're called parallel lines, and we have a notation for writing the two lines are parallel. It's the names of the two lines with a pair of little vertical parallel lines in between them. Now, where things start to get interesting is if we had a third line called a transversal that cuts across the two parallel lines. In this situation, we get a collection of 8 angles where some of the pairs have special names. I'm going to go through the definitions here because they can get a little wordy, but they're wordy for a reason. Right? We're trying to be very specific and make sure we come up with these definitions that say exactly what we mean and don't accidentally let additional angles slip into the mix. So, alternate interior angles are angles that are between the two parallel lines, right? So that rules out angles 1 and 2 and angles 7 and 8. But on opposite sides of the transversal, okay, so far that could mean 3 and 4, or it could mean 4 and 5, among others. Right? But there's one more part. They also don't have a common vertex. Right? So that means 3 and 4 can't be alternate interior angles because they have this common vertex here. Similarly, 5 and 6 can't be alternate interior angles because they also have a common vertex. So what that leaves us with are angles 3 and 6, that's one pair, and angles 4 and 5, that's another pair. So let me start making a list here. Angle 3 and angle 6 are alternate interior angles, and angle 4 and angle 5 are alternate interior angles. So let's try the next one. All right, the next one is alternate exterior angles. So these are angles that are on the outside of the two parallel lines. We're kind of going the other way this time. So we're going to rule out 3 and 4 and 5 and 6. So they're outside the two parallel lines and on opposite sides of the transversal and don't have a common vertex. Right. So again, that rules out 1 and 2 and 7 and 8 because while they are outside, they have that common vertex. Right. But it does allow 2 and 7. So let's make my list here again. Angle 2 and angle 7. And angles 1 and angle 1 and angle 8. Those are also outside the parallel lines, opposite sides of the transversal, and they don't have a vertex in common. So we've got two pairs of this kind of angle. All right, and finally, one more, corresponding angles. Corresponding angles are angles on the same side of the transversal, one interior and one exterior, and again with a different vertex. All right, so see if we can't find some that do this. So they have to be on the same side of the transversal. So let's just look for now over here at the right side. We're not going to look at these. One interior and one exterior. So how about 2 and 4? Would that work? Well, no, because 2 and 4 have the same vertex. Right, so we've got to rule those out. So two that are on that side and that have different vertices. We're looking at 2 and 6. That's one pair. And 4 and 8. That's another pair. So let me make a list again. Angle 2 and angle 6 and angle 4 and angle 8. Well, okay, that's good, but how about the left side? I wrote out the left side just for convenience and narrow down what we were looking at. But everything we said about the right side also applies to the left side. So angle 1 and angle 5 are going to be corresponding angles, and angle 3 and angle 7 will also be corresponding angles. So what can we say about these pairs of angles? 'Cause we didn't just come up with all of these definitions just for sport. right? What we can say about all three of these kinds of pairs is that if you pick any pair of angles that are in one of these three relationships with each other, those angles are going to be congruent. They're going to be the same size, have the same angle measure. Right. So now I know I'm always talking about you should never make assumptions based on a diagram. Right? You should never assume that just because two angles look congruent that they are, just because an angle looks like a right angle that it is. Okay, but when we get to this, I always tell my students it's okay to use the diagram as a memory aid. Right? So when I look at this, I can see clearly that angle 2 and angle 6 are congruent, assuming that those lines are parallel. Right? I can tell that angles 7 and 3 are congruent. And again, I'm not trying to assume that they are. I'm just using this diagram as an aid to help me remember which pairs have this special relationship. The next lecture, we're going to look at a couple of classic examples of the kinds of questions that you get asked about parallel lines that have all of these transversals drawn in them. And we'll see how, given certain pieces of information, we can calculate the measures of all of the other angles in the diagram.